back to the channel. In this video, we're going to talk about how to graph quadratic functions in the form f of x equals ax squared plus c. So in a previous video, we talked about how to graph f of x equals ax squared, so I'll link that in the description below. Here, the only difference here is this c, and what it does is it translates our parabola either up or down, depending on the sign of c. So here we see right here with this star that if c is greater than 0, so if c is positive, so if we have plus a number, we're going to translate the graph up, and so that is what this parabola would represent here. Notice how our points have been shifted up, our vertex has moved up, all other points on the parabola have moved up the same amount, and that amount is whatever c is. Now if c is less than 0, that's a negative number, so that would be something minus, right? -5, -6, whatever. Then that's a vertical translation that many units down. Okay, so if we have -2, then we're just going to move all of our points 2 units down. Okay, so what does this do to our axis of symmetry, and what does it do to our vertex? Well, compared to our parent function, the axis of symmetry does not change. It's still x equals 0 because we're not moving left or right here. We're only moving up or down. So our axis of symmetry is actually still the y-axis, which is just x equals 0. However, our vertex can change. The part of the vertex that won't change is our x value. So our x value is still 0, but our y value will just be whatever c is. Okay, so remember we're starting with our vertex at the origin. So if our equation says +5, then our vertex is going to move up to 0, 5. If our equation says -8, then our parabola is going to move down and our vertex would be 0, -8. Okay, so let's look at a couple examples here. Example 1 says we're going to graph g of x equals x squared minus 5 and compare it to our parent function. So let's graph the parent function 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. Okay, so here's our parent function right there. And now we're just going to graph x squared minus 5. So that -5 right there just tells me move all of those points down 5 units. So the vertex 1, 2, 3, 4, 5. Vertex will move there. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. So here's what our new parabola would look like. So we can say g of x is a vertical translation, 5 units down, and that's all it is. Okay. All right, let's see if we combine some of these transformations. So we talked about the video we did on ax squared, and we said a was a vertical stretch or shrink, and so here we have 3x squared plus 2. So we're going to have a vertical stretch, and we're also going to have this vertical translation. So we're going to compare to our parent function, so we'll go ahead and graph that one. 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. So there's our parent function, and we'll switch back to red here for our g of x function. Okay, so we're going to use our table of values, -2 to 2. We're going to plug these values in for x. We're going to square it, multiply by 3, and add 2. Okay, so -2, plug in right here. -2 squared is 4. 4 times 3 is 12. 12 plus 2 is 14. -1 squared is 1. 1 times 3 is 3. 3 plus 2 would be 5. 0 squared is 0, 0 times 3 is 0, but then we get 0 plus 2, which is 2. And so now remember, these points are symmetrical because they are on the opposite side of that axis of symmetry. So now we can plot these points. Okay, now we have 0, 2. We have 1, 5, and -1, 5. And then we have 2, 14, which is all the way up at the top, and -2, 14. Okay, so now when we graph this one, there we go, we see a couple things, right? It's a lot more narrow, so we can say g of x is a vertical stretch by a factor of 3, followed by, and so the key here on a parabola, look at your vertex. Where'd the vertex go? Well, it went up. It went from 0, 0 to 0, 2. So we followed it by a vertical translation. Vertical translation. 2 units up. Okay. All right. Last example. Okay, now we have f of x equals negative 0.25 x squared plus 1, and g of x equals f of x minus 4. So don't be confused when it says negative 0.25. That's just like having negative 1/4, right? We've seen one of those before in a previous video. It says describe the transformation from f of x to g of x, and then write an equation that represents g in terms of x. Okay, so let's go ahead and use our table of values to graph the f of x function. So once again, we're working with a fraction of 1/4. So I'm going to plug these values, negative 4, negative 2, 2, and 4, into my equation for x. So I'm going to plug these values right here. So negative 4 squared, and we get 16. Okay, now we're going to do, remember this is like negative 1/4. So 16 times negative 1/4, and we get negative 4. Plug in negative 2. Negative 2 squared is 4. 4 times negative 1/4 would be negative 1. Okay. And then we do 0 squared, 0. And then these are symmetrical, so negative 1 and negative 4. Okay. But remember, we do have this plus 1 right here. So now we can go back to all of these terms and just add 1. So negative 4 plus 1 would be negative 3. Negative 1 plus 1 would be 0. 0 plus 1 would be 1. Negative 1 plus 1 would be 0. And negative 4 plus 1 would be negative 3. Okay, so now we have our coordinates for our f of x function, and we can go ahead and graph that. So we're going to start with 0, 1, 2, 0, and negative 2, 0, 4, negative 3, and negative 4, negative 3. Okay, so now let's graph that one. Here we go, not too bad. Okay, so now let's look at the g of x function. Okay, so now g of x just says, hey, take your f of x function and subtract 4. So we're going to look at the f of x column, or the f of x row, and all of those values, negative 3, 0, 1, 0, negative 3, we're just going to subtract 4. So we get negative 3 minus 4, negative 7, 0 minus 4, negative 4, 1 minus 4, negative 3, and then 0 minus 4, negative 4, and negative 3 minus 4, negative 7. So now we can graph that one. So we have 0, negative 3, we have 2, negative 4. So look what we're graphing now. We're graphing these two rows. So 0, negative 3, I'll highlight them for us. 0, negative 3, 2, negative 4, and negative 2, negative 4. So 2, negative 4, and negative 2, negative 4. And 4, negative 7, 4, negative 7, and negative 4, negative 7. And we have our graph. Okay. All right, so a couple things we should notice about these two parabolas. Okay, they should be open the same amount. All right. Now, based on my drawing, the red one, maybe not, but they should be open the same amount because the stretch or the shrink, that vertical shrink we have, the negative 1/4, is the same on both of these equations. Okay, so we just described the transformation from f of x to g of x. This negative 4 right here just means to vertically translate 4 units down. Vertical translation, 4 units down. So now it says write an equation that represents g in terms of x. Okay, so we could say g of x equals f of x minus 4. That's what we had right here, right? Well, we know f of x is equal to this right here. So we could say g of x equals negative 0.25 x squared plus 1, and now we have minus 4. Okay, so now we can combine these like terms. So g of x equals negative 0.25 x squared, and 1 minus 4 would be negative 3. And there's our equation for our pink or our final parabola. So this should tell us, remember what we said c was, that's our vertical translation, that's where our vertex should be located. So look at where our vertex is located, 0, negative 3. Okay? And that's how you graph a quadratic function in the form f of x equals ax² plus c.